Hello everyone, welcome back to my YouTube channel. How are you all? I hope you all are doing good. By the way, I am Bhumika V, pursuing my Computer Science and Engineering from Sri Venkateshwara College of Engineering, Bangalore. Today, I am here to explain the topics like surveying, water resource engineering, and geotechnical engineering. Let's move on to the topic. First of all, let us know what is surveying. Surveying or land surveying is the technique, profession, art, and science of determining the terrestrial two-dimensional or three-dimensional positions of points and the distances and angles between them. What are the instruments used in surveying? Let's know about it. Some of the common instruments used for surveying is as follows. That is chain, tape, compass, auto level, theodolite, total station, GPS and drones. First of all, let us know about classification of surveying. Surveying is classified into two types, that is plain surveying and geodetic surveying. First of all, let us know what is plain surveying. Plain surveying is the method of measuring small areas of the Earth's surface by disregarding curvature and geoid effects. It relies on a local coordinate system such as the Universal Transverse Mercator, shortly known as UTM, to determine the positions and elevations of points on a flat plane. The surface of Earth is taken to be a plane surface in plane surveying. The extent of area up to which this assumption of plane surface holds good is about 260 square kilometers. Therefore, plane surveying is adopted for small areas. Let us know about geodetic surveying. Geodetic surveying is a method of measuring large areas of the Earth's surface with high accuracy and precision. It uses a reference system such as the World Geodetic System 1984, shortly known as WGS84, to define coordinates and elements of points on the Earth. In geodetic surveying, the curvature of the Earth is taken into account. Geodetic surveys are carried out for large distances and areas with a high degree of precision. In India, Survey of India, a government department, undertakes the work of geodetic surveying. Now about water resources engineering. Mainly, water is such a commodity that is vital for the existence of mankind. Human beings, animals and plants require water for their survival. Surface water is easy and economical to harness. However, its availability cannot be relied upon continuously since it varies with the season. Water resources engineering can be defined as the science which deals with the subject of tapping water either from the surface or subsurface sources. A water resource is such a vast subject that it includes in itself hydrology, irrigation, hydraulics and water supply. Water resources engineering is the study and management of equipment, facilities and techniques that are used to manage and preserve life's most plentiful resource. Tremendous volume of water is stored in the Earth's crust. The use of surface water for irrigation is likely to create problems like waterlogging in certain areas. Groundwater is obtainable all the year round and its use along with the surface water keeps the subsoil water level within reasonable limits. The judicious use of water for purposes of irrigation has gained such importance in the recent times that water management has become a science in itself. Engineers have learned to tame the water resources by construction of dams, construction of bore wells, and construction of hydroelectric plants for the benefit of mankind. Let us know what are the elements of water resources engineering. It specifically deals with the principal segments of water resources engineering, which include hydrology, groundwater, water management for irrigation and power, flood control, engineering economy in water resources projects for flood control, project planning in water resources, concrete and earth dams. What does water engineer do? Let's know about it. Design or oversee projects involving provision of potable water, disposal of wastewater and sewage, or prevention of flood-related damage. Prepare environmental documentation for water resources, regulatory program compliance, data management and analysis, and fieldwork. These are the works that water engineers do. Let us know what are the scopes of water resources engineering. To record the total discharge of water from rainfall from catchment areas, to design the reservoir capacity to store the water, water quality management and pollution control, scope for usage of water for garden and recreational centers, design of water supply systems for the cities and industries, flood mitigation, land drainage and culverts for control of water. Here comes the importance of water resources engineering. The main responsibility of a water resource engineer is to manage a population's water use and ensure that the treatment of water is safe for human consumption. The typical day of a water resource engineer may entail charting out a community's water needs and frequently analyzing water resources. What is the significance and scope of water resources? Let's know about it. Water resources are used in various fields such as agricultural, industrial, domestic, recreational, and environmental activities. Most of the uses require fresh water. However, around 97% of the water on the earth is salt water and only 3% is fresh water which can be used. Now about geotechnical engineering. This branch of civil engineering is also called soil mechanics and it's also known as geotechnics. It is a discipline of civil engineering in which the study of soil, its behavior on the application of load, and its use as an engineering material in the construction of earth dams. The properties and strength characteristics of different types of soil are studied in this subject. The knowledge of this subject is useful in the design of earth dams, different pile foundations, buildings, foundations, etc. The geotechnical engineering concerned with the engineering behavior of earth metals. It uses the principles of soil mechanics and rock mechanics to solve its engineering problems. What are the finite elements in geotechnical engineering? In geotechnical engineering, the frequently used term, that is, the finite element modeling, refers to a numerical technique whereby engineering structures and their surrounding soil are decriticized into certain numerical elements that specific constitutive laws. What does a geotechnical engineer do? Geotechnical engineers investigate and evaluate soil, rock, groundwater, and man-made materials and their interaction with earth retention systems, structure foundations, and other civil engineering works. Let us know what are the following scopes of geotechnical engineering. To access the quality and strength of soil or rock to construct civil engineering structures, to design retaining walls for soil retainment, to decide type of foundations for different type of structures, for design of underground structures such as tunnels, shafts, conduits, etc. Design of earthen dams for storage of water, for the design of roads for transportation facilities. What is the importance of geotechnical engineering? Let's know about it. Geotechnical engineers use their expertise to minimize the impact of projects on the environment, such as the protection of soil, water, and air quality. They also use their knowledge to design structures that are sustainable and resilient, such as green roofs and permeable pavements. Let us know what is the scope of geotechnical engineering in our country, that is, in India. Geotechnical engineering has applications in military engineering, mining engineering, petroleum engineering, coastal engineering, and offshore construction. The fields of geotechnical engineering and engineering geology overlaps with the knowledge areas. Thank you for watching. Please do like, share, and subscribe to my channel.